Hello friends, welcome to Actual Diamond Academy. In the last lecture, we have started the discussion on the stable and unstable equilibrium. Also, we have seen two important problems on the stable and unstable equilibrium. So, in the last lecture, we have discussed up to question number 2. So, we will discuss question number 3 onwards in this particular lecture. So, let's start our discussion. So, what we have seen in the last lecture is that the basic condition for the stable and unstable equilibrium is for stable equilibrium. For stable equilibrium, we have 1 upon rho 1 plus 1 upon rho 2 is less than 1 upon h, and for unstable equilibrium we have 1 upon rho 1 plus 1 upon rho 2 is greater than 1 upon h, where rho 1 is the center of gravity, rho 1 is the radius of curvature of the upper body, rho 2 is the radius of curvature of the lower body, and h is the distance of the center of gravity of the upper body from the surface of contact. Okay, so let us consider two surfaces. This one is first surface, this one is second body. Okay, so this is first body and this is second body. So the radius of curvature of first upper body is rho 1 and radius of curvature of lower body is rho 2, and the distance of center of gravity of the upper body from the line of surface of contact is h. Okay, so this is rho 1, this is rho 2 and this is h. So these are the conditions for the stable and unstable equilibrium. Okay, so this we have discussed in detail in the last lecture. Also we have seen if one of the body is a plane surface, okay, then the radius of curvature will be infinity. Suppose we have two bodies like this. This is a sphere and above that there is a cuboid. Okay, so this is surface is a plane surface, so rho 1 will be infinity, and suppose this is a radius r, this sphere is of radius r, then the radius of curvature rho 2 will be r. Okay, this we have discussed. One more concept is that suppose two bodies are in this particular fashion. Suppose this is and the second body is the first body is in this particular fashion. Okay, two bodies are placed in this particular fashion. Okay, so this is the upper body and this is the lower body. Okay, so this is placed in an inverted fashion. Okay, so suppose the radius of this is this shell is b and this is of radius a. Okay, so the radius of curvature upper body rho 1 will be a, and this is in inverted fashion. Okay, inverted fashion, so the radius of curvature of this lower body rho 2 will be minus of b, because suppose it was in this particular fashion, then the radius of curvature was rho 2 is equal to b, and this is, we have inverted this, so this is in this particular fashion, so the radius of curvature will be minus times of b. Okay, so these are the concepts that we have seen in the previous set of lecture. Now let us start discussing these problems. Okay, okay, so in the question number 3, we have a uniform solid sphere rests in equilibrium upon a rough horizontal plane with its curved surface in contact with a plane, and a particle of mass small m is fixed at the center of the plane face. Show that for any value of m the equilibrium is stable. Okay, let us draw this rough horizontal plane. Let us draw a rough horizontal plane. So this is a rough horizontal plane. Okay, and a uniform solid hemisphere. So let us draw the hemisphere. Okay, so this is our hemisphere. So this is our hemisphere, and a uniform solid hemisphere rests on in equilibrium upon a rough horizontal plane. This is rough horizontal plane with its curved surface in contact with the plane. So this is the curved surface. So this curved surface is in contact with the plane, and a particle of mass m is fixed at the center of plane face. So this is our center of plane face, and there is a particle of mass small m. Okay, is fixed at the center of plane face. So this is the center of this is plane face, so this is the center of plane face. Okay, show that for any value of m the equation is stable. Okay, so we have considered, so this is the plane surface, so this is lower body. So this plane surface the surface below this one. So this is a plane surface. So in this particular case, so we have the equation of stable equilibrium is 1 upon rho 1 plus 1 upon rho 2 is less than 1 upon h. Okay. So rho 1 is the radius of curvature of the upper body. Okay. So let us take the radius as r. Okay. So this rho 1 will be r and rho 2. For rho 2, this is a plane surface. So rho 2 will be infinity. So this rho 2 is infinity. So we have 1 upon r is less than 1 upon h. So this means h is less than r. Okay, so the condition here is h is less than r. Now let us find the value of h. So h is the distance of center of gravity of this combined system from surface of contact. Okay, so the center of gravity of this is hemisphere from this top. So what is the center of gravity of a hemisphere? So suppose this is a hemisphere. Okay, so the center of gravity lies here at a distance of 3r upon 8 from the plane surface, and from the curved surface it is r minus 3r upon 8. This is 5r upon 8. So from this particular point, let us take the CG. So CG will lie somewhere here. Okay, so the center of gravity of this hemisphere alone will be, this distance will be 5r upon 8. Okay, 5r upon 8. This is the center of gravity. Let us take this as G1. Okay, and this as G2. And the center of gravity of this mass M will be lie as this particular point, that is center of the plane surface, that is at, let us take this as G2. Okay, so the combined center of gravity will lie somewhere here at this particular point. So let us take this as h. So this distance is h. Okay, so the h will be, so let us take this as G1, this is G1 and this is G2. Okay, so the h will be m times of, and let us take mass of this hemisphere alone is capital M. Okay, so we have the center of gravity of the combined system consisting of this small this particle of mass M and this hemisphere. Okay, so let us take the mass of this hemisphere as capital M. Okay, so we have the for combined system, center of gravity will be m1 y1 plus m2 y2 upon m1 plus m2. Okay, so here m1 is small m, m2 is capital M, y1 is og1 and y2 is og2. Okay, so let us place the value. The h is equal to m times of og1. Og1 is this distance, that is r, plus the value of m2 is capital M, m times of og2. Let us take this point as o. This is og2 and this is og1. So og2 will be 5r upon 8. So this is 5r upon 8. Okay, this y2 is og2. So this is the center of gravity of the hemisphere from this surface. So this is 5r upon 8 upon m plus capital M. Okay, and we have the condition as h is less than r. So clearly this is less than r. So we have this as mr plus 5m upon 8 into r is less than mr plus capital Mr. So this mr gets cancelled, and we have 5m upon 8r is less than capital Mr. So this gets cancelled, r gets cancelled. This means 5 is less than 8, which is true. Which is true. Okay, so this complete system will be in equilibrium. Okay, so this complete system will be in equilibrium for any value of m, because this expression is independent of m. So this is independent of mass m. Okay, so this system is in equilibrium and is independent of value of small m. Okay, so for any value of 1, this whole system is in equilibrium. Okay, so now let us discuss question number 4. Okay, so let us discuss question number 4. In the question number 4, hemisphere rests in equilibrium on a sphere of equal radius. Show that the equation is unstable when the curved surface and the stable when flat surface of the hemisphere rests on the sphere. Okay, so there are two cases. In the case 1, we have a sphere like this and the curved surface of the hemisphere. Curved surface of the hemisphere rests on the this sphere. And in the second case, we have the plane surface. Plane surface rest on this hemisphere. Plane surface of the hemisphere rest on the this sphere. Okay, and the radius is equal. So this is a small r, this is also a small r, and the radius of this hemisphere is small r. Radius of this hemisphere is small r. So let us find the this is the plane of surface of contact. Plane of surface of contact. Okay. So this is the plane of surface of contact. This is upper body, this is lower body. This is upper body, this is lower body. Okay. So the condition for what we have to show, this is case 1. Case 1, this is case 2. In the case 1, we have to show equilibrium. Equilibrium is unstable. Okay, and this we have to show equilibrium is stable. Okay, so the condition for unstable equilibrium is 1 upon rho 1 plus 1 upon rho 2 is greater than 1 upon h. Condition for stable equilibrium is 1 upon rho 1 plus 1 upon rho 2 is less than 1 upon h. Okay, so we have this in this particular case rho 1 will be r, and rho 2 will be small r. So 1 upon r plus 1 upon r is greater than, and h is the height of center of gravity of the hemisphere. Okay, so this is inverted hemisphere. So the center of gravity will be at a distance of 5r upon 8. Okay, so this is upon 1 upon 5r upon 8. So this is 2 upon r is greater than 8 upon 5r. Okay, so let us divide by 5 in numerator and denominator. This is 10 upon 5r is greater than 8 upon 5r. So this expression is true. This means this equation is valid. Okay, so this means this equilibrium is unstable. Now let us discuss this one, case 2. Okay, so this is the flat surface. So the rho 1 will be infinity, and for the bottom surface, this is rho 2 will be r. So this is 1 upon infinity plus this is 1 upon r is less than 1 upon. So this is the center of gravity from the plane surface is 3r upon 8. This is 3r upon 8. This is the value of h. So this is 3r upon 8. So 1 upon r is less than 8 upon 3r. Okay. Let us divide by 3 in numerator and denominator. So this is 3 upon 3r is less than 8 upon 3r. So 3 is less than 8, which is true. This is true. This means this expression is valid. This means the equilibrium is stable. Okay. So now let us discuss question number 5. So what is given in the question? A body consists of a cone and a hemisphere on the same base rest on a rough horizontal table. The hemisphere being in contact with the table show that the greatest height of the cone so that the equilibrium may be stable is root 3 times the radius of hemisphere. Okay, so let us solve this. So we have hemisphere, body consists of a cone and a hemisphere. Okay, so we have a cone like this. Okay, and a hemisphere like this, and this combined body rests on a table. This is our table. Okay, so the center of gravity of this cone, let us take the height of this cone as capital H. The center of gravity G1, center of gravity of this cone will lie at this particular point, that is at a distance of h upon 4 from the plane surface. This is the plane surface. So this is h upon 4. Okay, and the center of gravity of this hemisphere, inverted hemisphere, will be at this particular point G2. This is at a distance of, let us take the radius as, a small r. Okay, let us take the radius of hemisphere as a small r. So this is it, this so now let us take this point as O. So the position of this center of gravity of the hemisphere will be at a distance of 3r upon 8. Okay, this is OG2 is 3r upon 8. Sorry, this is 5r upon 8. 5r upon 8. Because in case of a hemisphere, the distance of the center of gravity from the plane surface is 3r upon 8. So from curved surface it will r minus 3r upon 8, that is 5r upon 8. Okay. So for the combined system that is consisting of cone and the hemisphere, the center of gravity will lie somewhere here. Okay, somewhere here it will lie at a distance of h, from this surface. Let us find the value of h and let us take the density as rho. Okay, and let us take this as m1, mass of this cone as m1 and mass of this hemisphere as m2. So we have the value of h as, h is the center of gravity of this combined system. So h is equal to m1 into, this distance is OG1, that is distance of center of gravity of the cone from this surface, that is surface of table. This is m1 into OG1 plus m2. m2 is the mass of this hemisphere into distance is OG2. G2 is the distance of center of gravity of this hemisphere from this surface upon m1 plus m2. H is equal to, the value of m1 is density times of 1 by 3 pi r square into height capital H into OG1. This is h upon 4. H upon 4 plus h upon 4. OG1 will be this distance h plus 4, h upon 4 plus this radius plus r plus m2. Value of m2 will be density times of 2 by 3 pi r cube. This is mass into volume. This is density times of volume will be mass. This is mass. This is the value of m2 into OG2. OG2 will be 5r upon 8. Okay. So OG1 is the distance of center of gravity of this cone from this surface. Okay, this distance, this complete distance is h by 4 plus radius. And now for this hemisphere, the mass is density times of volume. So rho is the density and volume is 2 by 3 pi r cube. This is the mass times of distance of the center of gravity of the hemisphere from this surface, that is OG2. OG2 will be this distance, that is 5r upon 8 upon m1 plus m2. So rho times of 1 by 3 pi r square h plus rho times of 2 by 3 pi r cube. Okay, this is the value of center of gravity of this combined system from this surface of the table. Okay, so h will be equal to, let us cancel this. So 3 gets cancelled, rho gets cancelled, and let us take pi r square common. So pi r square into h times of h upon 4 plus r plus this 2 gets cancelled, 4. So this is 5r square upon 4. Pi r square we have taken out, so we have r. So 5r square upon 4 upon, let us take pi r square out. So this is h plus 2r. Pi r square we have taken out. So this pi r square gets cancelled. Okay. So now let us apply this condition for the stable equilibrium. So the condition for a stable equilibrium is 1 upon rho 1 plus 1 upon rho 2 is less than 1 upon h. So radius of curvature of this upper body. So radius of curvature of the upper body will be, so this is the curved surface. So the radius of curvature will be r. So 1 upon r plus rho 2. So this is the plane surface. So the surface bottom to this. So this is plane surface. So this is 1 upon infinity. So rho 2 is infinity. Is less than 1 upon h. This means h is less than r. This means this particular expression is less than r. Okay, so this particular expression is less than r. So we have h square upon 4 plus hr plus 5r square upon 4 is less than hr plus 2r square. hr plus 2r, because this particular, the value of h is less than r. Okay, from this particular expression. So we have hr gets cancelled. So we have h square upon 4 is less than, this is 3r square upon 4. So this gets cancelled. So from here we have h square is less than 3r square. So we have h square is less than 3r square. This means h is less than root 3r. Okay, so we have the greatest height. So we have the equilibrium may be stable. So the greatest height of the cone, so that the equilibrium may be stable, is root 3 times the radius of hemisphere. So the greatest height is root 3 times the radius of hemisphere. So radius of hemisphere we have taken as a small r. Okay, so we have discussed up to question number 3. So we will discuss further questions in next particular lecture. Thank you.